Hi, this video is regarding one of the assignments related to time series case study. So time series case study was one of the lined up assignments during our upgrad with IIIT Bangalore, and this case study deals with one of the major topics which discussed that we had during this course module program, that is time series. So first of all, we had some line of questions here, which basic starts with what the assignment problem and what we did to provide the solutions for that. So we had the online store Supergiant for X and Y, which is having a worldwide operations, and it takes orders and deliver across the world with other major product categories, like which is consumer, corporate, and home offices. Now, being taken as an on sale or sales operation managers, we want to finalize the plan for the next 6 months, and so we want to forecast the sales and the demand for the next 6 months, which that would help the revenue of the company. So there were basics understanding of the data. So the data has a transaction level data, which has mainly particular order made on the online data stores, and then we need to have some data preparations, which also need to start from the initial segments of the data. That then we need to have a 21 subsets as per defined in the assignments. We have 21 subsets, and then you have to proceed next step by steps, and then that proceed with some model building, model evolutions, and other regressions methods using in time series module. So there are few of the questions which are being lined up here, similar to my previous one of the videos in our linear regressions. So there are a few lineup questions as which methods do we use to model time series. Now, time series forecasting with the multiple seasonal cycle is a subject of is a special area of interest, and we used basically use of patterns for seasonal cycle, and these patterns use the input output variables for taking this, simplifying the forecasting problem. Now it's for our side, we use our uh, model based uh, we used different models like similarity based model, but neural networks and linear regressions, but here we used as a AR an exponential smoothing. So we use this model, and there are basically we used because ARMA stands better than other two models, which other ways of forecasting this time series. Now moving on to next segmented part of these questions: why do we use classical decompositions, or how does this classical decompositions work? So classical decomposition has two forms. One is additive and a multiplicative. So decomposition for time series is a statistical task that's mainly deconstruct a time series in several components, and it's representing one of the underlying categories of patterns. That what we define patterns is some of the it's maybe a trend pattern or a seasonal pattern. Like there might be some, you might be getting some of the similarity, or some you can get some trend in this seasonal. Like for example, seasonal trend is like summer. We would be getting for a whole entire year. During a year, the temperature is high during the summer, it's bit on the mid average level in the month of monsoon, and then it decreases bit below on a suitable level during the winter time. So this is a seasonal trend in the temperature rise of the whole year. But what trend is, the trend goes for a sudden, like stock exchange prices increases, so that goes for a trend. Now goes for another line of question: how does auto ARMI works? So auto ARMI basically models according to the AIC and AIC and BIC values. So there are very other methods, which I would rather to say that uh, it basically deals with the possible model with other constraints provided. Now there are what other methods where we can also use modeling time series. So there are other like SMA, that is simple moving average, exponential smoothing, and the neural networks also, and autoregressive integration moving average, that is ARMA. Now there are another line of questions which, how, why time series smoothing necessary? Necessary is not a right what we will prefer for time series forecasting, but some people utilize smoothing in time series forecasting, might want a simplified view of the data that they want to predict in this, and we have also used here. But the cost, however, here for the value of the interpretation is depends upon certain factors also. Now moving on to some of the other questions, which, like, which methods are need to check whether time series is a white noise or not. So we have used like lung box first test method for several lags, or if a testing observation auto correlated. Now moving on to another questions, why stationary time series is necessary, and what is stationary time series? Stationary time series in a statistical term is one with statistical properties or such as mean, variance, autocorrelations are exist or constant over the time. That's what stationary terms for. That's any common assumption in many time series technique, is that data are stationary, and a stationary process has the property that the mean or variance or relation doesn't change over the time. Now moving on to what are the other questions, what factors, what parameters are generally used to evaluate the fit of a time series model. Now there are methods which the mean absolute percentage error, which is a MAP, is also known as a MAP, mean absolute percentage, is a measure of predicting accuracy for a forecasting method in statistics, like example in trending estimation. It expresses accuracy of as a percentage and as defined as some of the formulas, which there are different formulas in statistics that mainly follows. But one of the main major question that trends how we determine the patterns in time series data. There are various methods where we find ARMI methods, interrupted time series, then exponential smoothing. These are the various methods which where we can have this time series determination of the where we can have and define the patterns in the time series data. So thank you for that.